Hi, this is the poem that doesn't end, or the poetics of RNG. I'm Alicia, a computational poet, artist, and researcher in creativity support tools. And today I'll be talking about one of my projects, but what I'd really love to share is the spirit of poetic computation and hopefully leave you with a sense of being able to create your own computational poetry. This was a poem I wrote sometime last year called Some Things to Be, inspired by one of my favorite poets, Chen, and his poem, When I Grow Up, I Want to Be a List of Further Possibilities. And isn't that such a lovely sentiment? There's the feeling of possibility in the exercise of thinking of things to be, and it was so hard to settle on just a few lines for this poem because there are so many things that I want to and could be. So that led me to wonder, what are all of the other things I could be? So I created this to be endless, infinite poem of endless things to be. It's a browser experience you can scroll on forever and find new things to be, and each refresh will bring up new possibilities. To be duller, to be a nautical intuition, to be static, to be vigilance, to be audacious and errant, to be aesthetically misleading, to be one last harmonic presenter. And you can tell there's an algorithmic flavor to it. And at first it might seem like it doesn't even make sense, it might not even be grammatical, but the human brain is amazing at filling in gaps and creating meaning, and suddenly you want to be loved for your unjust fuzz. Or maybe you want to be intimately random and fastidious, or to be bluntly academic and unintelligible. And for sure, I want to be loved in strategically litigating ways. So the way that I created this poem was with a grammar, and the same code that created To Be a Good Prey also created To Be a Brighter Activist Despite Our Obedience. And I'm going to get into the details of how this works because I think grammars are so wonderful and powerful for how simple they are. Starting with a simple example for how grammars can generate text, we can think of it as a set of rules for expanding text. And we'll start with to be something, and we don't know what we want to be yet, so we have a variable or placeholder. And maybe I want to be occasionally refreshing from my original poem. So I can have an adverb and adjective, and maybe I want something else. So another option could be a good noun. And we're still not done. We have to fill in these placeholders. So I'll just pick some random words for each of these parts of speech. And we're now ready to start expanding our grammar. We begin with the start phrase, and then randomly choose our options from phrase. I'll go with adverb, adjective. And then for each of those, also expand randomly. And suddenly, we get to be softly absurd. And we have just created a small poem. And this small grammar gives us 15 distinct possibilities. And we can think of grammars as a structure for defining language. From this wonderful article by Matt.Might, grammars are the language of languages. And I'll start off with, you don't need to read any of this, but the type of grammar we used is a context-free grammar, and I'll get into a bit more why it's called that later. But there is a formal definition for those of you that are curious, and then here's an easier definition. We have a starting point, a set of non-terminals, and then a set of non-terminals that can be expanded further, and a set of terminals that can't be expanded further, and then a set of rules for expanding those non-terminals. As I alluded to earlier, there are different types of grammars, and they differ by the rules of expansion and the complexity of the languages they can generate. So these are ordered by their generative power, and they are used in many different areas in math, linguistics, and programming languages. Regular grammars are the most restrictive. Recursively enumerable or unrestricted grammars are the most powerful, and in the middle we have context-free grammars, which allow for nested patterns and are called context-free because their rules for reduction don't rely on the surrounding elements, so they don't rely on the surrounding context, and these are great for poetry. And how do you create your own grammars? There are many tools available online, like Tracery, created by Dr. Kate Compton. This is an example of the web editor where you can just jump in and start creating your own grammars. There's also Rita, which has some more advanced capabilities and is what I use to create my To Be poem. So I lied a little bit. It's not really infinite. There are only this really large number of possibilities, which if you viewed a new one each second would take you over 1 million years. But if you wanted to make this truly infinite, you could have a rule that recursively goes to itself, and then you have an infinite list of adjectives to be. There are other applications if you've seen any of these Twitter bots. These were created with grammars from a tool, Cheap Bots Done Quick. There are also other poetic experiences you can create with grammars. And here is another poem that I created with grammars. It's an experience in the web asking what lives behind the web, and can you just sit and window watch on your browser? And I want to ask what makes these so compelling. If the grammar is the bones of the poem, then I think randomness is the soul that makes it alive. It brings back the play and playing in language, allowing one to ignore the expectations for what should be and live in the could be. And in code, when I'm working in the browser, this means math.random, one of my favorite functions. But how does that actually work? It actually depends. Your browser gets to decide how math.random is implemented. And nowadays, it's usually this function, XOR shift 128 plus. It's a deterministic algorithm that just takes a really long time to repeat, so the numbers appear random, but it's called a pseudo random number generator. And you probably won't be using it to secure important information, but it's really good for poetry. And random number generators existed long before computers. We have, as far back as 5,000 years ago, dice were used to determine fates. We had coin flips, and these are truly random because the outcome is not deterministic and cannot be predicted. But people got tired of rolling a bunch of dice, so they started creating random number tables. These random number tables recorded different random numbers that I could use. They could come from anything, such as the census, a telephone directory. Someone was rotating a cardboard disc with numbers on different sections in a dark room and just shining light on it to see whatever number was illuminated. And then there's finally, created by Rand's electronic roulette wheel in 1947, 1,000,000 random digits with 1,000 normal deviates. This was created with electronic pulses, and they just recorded a ton of numbers. It has a 4.49 on Goodreads. And I looked into some of the lower ratings, and I don't think they're quite fair. And a few years later, we have Ernie, a whole computer dedicated to generating random numbers using neon tubes and the decay of radioactive material. Another source of true randomness is a lava lamp. As some of you might have seen, Cloudflare uses these in their office with a camera that takes snapshots to convert these into random numbers as part of creating encryption keys. And there are other sources of true randomness, such as using hardware and quantum phenomena, atmospheric noise, or radioactive decay. So it makes you wonder, can anything radioactive be used as a random number generator? And someone tested this. This is an experiment from Valeria Nappi, testing to see if the potassium in a banana was enough. And it was, but also spoiler, the background radiation was also enough, so the banana was not quite necessary. But it gets you into thinking what inputs you can have as inputs for your program in randomness. There's also a rich history of randomness in creating text. This is called cut-up technique. You put in a bunch of words, cut them up, draw them out of a hat. There's also this wonderful, lovely table of types of light, and there was a poet who used this to create poetry by choosing random entries. There's also this, 100 million poems of 10 sonnets cut up that could be rearranged in any way. And I think of computational poetry in two ways, as the effect of computational processes like this, but also the new experiences that are made possible through code and interaction. This is a walking poem from Javier the Computer, and it takes your location and generates a poem that you can experience through walking. This one starts where we are all sitting, and if any of you would to try walking this poem, you'll end up somewhere 20 minutes and 0.8 miles from here, and I don't know where that is. And so as I think about my work, I love creating artifacts that create artifacts. And most of the times these poems come together in the process of creating, and only then does the poem begin to take shape. Here's a woven poem created in collaboration with friends where passersby could rearrange the words on fabric strips and weave a poem together. Computational forms that allow for many different arrangements lend themselves well to collaboration. And you can find me and my other computational pieces here. And I just want to say that computational poetry doesn't have to be with pen or paper or code, but any form that you can imbue with a computational process. And even if you didn't write it yourself, it can still express something very real. And randomness doesn't have to come from code, and it's probably better if it doesn't. Thank you.